Okay, so I'm going to show you the process of bacterial transformation using construction paper that I made. Alright, so here we have some DNA from a frog, and it contains codes that code for traits that make the frog itself. It makes it the frog. Now, in this genome, it contains a specific trait that codes for specific proteins that the frog uses. We want to copy this and insert it into bacteria in order to copy the gene and have more of it. We'll cut out this gene using a restriction enzyme. And a restriction enzyme is like scissors. It can cut in different places that are marked by the dotted line. There are different kinds of restriction enzymes, and this specific one we're using is EcoR1. So we will cut the DNA and we'll have different parts. Like that. Now we're going to have different parts of the DNA that are different from the gene that we want. So we'll deal with that later. So now we're going to use a bacterial plasmid and add our DNA. To do this, we will cut open the plasmid with our EcoR1. And then we need to add our frog DNA and let them join the plasmids. So we will take our gene and we will connect them using DNA ligase, which is like tape and fuses the DNA in place on the plasmid. Now, a specific thing about the plasmid is that the marker on it here makes it resistant to the antibiotic tetracycline, which we will use later. Now, after the process is done, we will have the plasmids that we contain the gene that we want, but we'll also have plasmids that have DNA that we don't want, and some plasmids that don't even take up any frog DNA. Next, we're going to want to insert them into bacteria. So here we have some bacteria, and you can see that it already has some DNA. And we're going to insert the plasmid by cooling the bacteria and then heating it up really fast so that there's holes in the membrane. Then the plasmid will slip through into the cell, and then the holes will close up. So after this process, we'll have bacteria with our plasmid, but then we'll also have bacteria that have other plasmids in them. And to separate them, we will first put the plasmid into a container that contains the tetracycline. So bacteria that didn't take any plasmids will stop growing, and we'll be able to see only the plasmids that we created. So then, after we've separated those bacteria out, We're going to distinguish the specific gene that we want from the others by extracting the plasmids again, so that and then we will use this and insert them into gel extraphoresis. And through this process, we'll be able to tell which contains our gene, and then we'll be able to make tons and tons of copies. This allows for things like insulin to be made, and it can save lives. So, thank you.